Ford here, and we're trying to basically the question that I had for him is what is different about this car versus the traditional car by Ford or Toyota.
That's
So
that's a good question. So here we have a lean car. What makes a car lean? There's a lot of stuff that makes this car lean, but let me show you a few of them to give you a couple of examples. First of all, you notice the gas tank. Here it is right here. It's tiny. I think it's 4 gallons. But if you're getting 100 miles per gallon, that's a 400-mile range, which exceeds the current range of most cars on the road. So by achieving efficiency, we've achieved some other things that are important to us, like lightweight, lower cost, and simplicity. It's worth it. Another thing is the frame of the car itself. It's made of extruded aluminum, simple pieces, locally available, easy to work with. It's not as complex of a frame as you'll sometimes see in tube chassis or what are called tube frame cars. They can be real works of art. Ours is kind of an abstraction of that, simplified down to the bare elements, the parts that are really necessary and essential. What you get with that is it's less expensive, it's lighter, and it's very, very strong. It will pass the impact test that we expect it to, and we don't expect people to sacrifice safety for something like this because that's one of the things that are important to us.
how much weight are you reducing by using this frame versus like comparison to a regular like Toyota frame?
It would be difficult to make that comparison because the modern Toyota doesn't use a frame at all. It's actually what's called unibody construction.
Okay.
So let's look at the whole car.
Right.
Uh, a new Toyota, say a Camry, probably weighs about 2 tons, somewhere in the vicinity of 4,000 pounds. Right now we're at about 1,400, so we're less than half that.
Great.
That's why the engine can be small, that's why the gas tank can be small. It's all kind of a big cascade of good effects.
Okay.
Yep. Another example of lean and agile shown in a mechanical form here is the suspension design. Now here you can see a combination of off-the-shelf and natively designed suspension components. But what's interesting is that all of these components bolt onto this 1/4 inch suspension plate. So we can unbolt that suspension plate with just 8 bolts. It takes about the same amount of time as it takes to take a tire off and bolt a whole new suspension plate on with a whole new suspension, which could radically change the nature of the car. This suspension is a road suspension designed for performance and, uh, and agility on the road. But by bolting that plate off and a different plate on with different suspension components, something you could never do in another car, you could radically change that suspension for a long travel off-road suspension or something more appropriate for agricultural use, for example.
Okay. So if you adjust this and you got like let's say you change the toe or like the three different axes, what does that do in terms of fuel efficiency?
Well, in our case, we want the wheels to move as straight ahead as possible. So things like camber, caster, toe in, we basically want it going straight down the road. For performance purposes, sometimes car designers will design a little bit of offset. For example, the tire might appear to be leaned in a little bit at the top when viewed from the back. That's called reverse camber, and that's done for performance reasons. Cars that are going through a corner really hard, they'll lean to the outside a little bit. If you imagine the car leaning to the outside, that would tend to tip the wheel over as well. Remember this, folks, for the best traction, you always want that wheel straight up and down to the ground, normal to the ground, not tipped or lean, because then your contact patch is messed up and the tire's just really not
So
working right.
neutral camber. And
Neutral camber in our case.
okay.
Yeah, but as I said, sometimes in a performance car on the road today, you might see a little bit of negative camber. That's in anticipation of the car leaning slightly in a turn, and then at that point, that wheel is now appears to be stacked up straight, and so you'll get maximum cornering force. The trade-off is a little bit more rolling resistance. A wheel isn't designed as much to roll at an angle down the road as it is straight.
So three things that made this car different than the traditional cars.
Well, those examples are frame, modular suspension, and tiny gas tank due to high engine efficiency. But the list goes on, and we'll make more videos to explain that to help people understand how we're going about making this very special car.
It's great, doctor. Thank you for your time. That
Thank
was a
you.
huge, huge understanding. Thank you. Bye.